to have Isha here.
So now we live in the age of information technologies, and everybody of us uses different types of electronic devices such as laptops, projectors, smartphones, camcorders, photograph, and other things. Well, but have you ever tried to think how all these things operate? And today I would like to talk about how, for example, does computer operate? And my main message would be, we'll try to look what it consists of, and that the major unit of the computer, it works as simple as a switch, which can switch between two states, like on and off, or in the digital electronics we say as 1 and 0. Okay, so seriously, let's have a look. What is inside of the computer? What do you think? Well, maybe that explains why some people, they can shake their devices, they can scream on them, and somehow they start working. But in real, if we try to open the keyboard, for example, the laptop, and try to see what are the parts of the computer, you would see that there is the skeleton of it. It's a motherboard, and there are many vessels or wires which connect many different elements with each other. And the heart or the brain of the computer is this small thing. This is the central processing unit, or simply people call it as a processor. So when you start the program, it sends some instructions to it, and that device, it will try to do all the operations as fast as possible. And you will not believe, I mentioned already about the switches on this inch by inch, on 2 inch by inch by inch piece of circuitry. There are about like 4 billions of these switches. So you can imagine you can put almost the whole Earth population there. How miniature are these things here. And of course, many of you would know about the hard drive. This is where you store the information, your files, and pictures, data, etc. And there is also things which is called rapid access memory. So if you want to store it for a long time, you put it, the information goes to the hard drive. It's like a hippocampus of our head, but if you would like to store information just temporary, and it's usually a fast memory, it's like a front lobe of our head or brain, and that's also called a RAM memory. Of course, there is a heating system or cooling system which keeps it down to some certain temperature, and of course the energy source. Well, the computer, you can see it's very complicated, and there are decades of engineering to bring all this to our everyday life. However, if you look in the history, the computers at some point they were just mechanical, or even you can look at Abacus's computer. So the difference between different computers is just the way they represent numbers. Let's have a look how would computer read, this electronic computer, read numbers. So that's what is called binary things. So computer can either say yes or no. In this case, 1, 0, true or false. For engineers, it would be plus 5 volt or 0 volt. And for our everyday life, we deal with decimal numbers. However, let's have a look at how the computer would interpret this number, 21. So we will write it as a sum of 16 plus 4 plus 1. You have probably noticed that these are the powers of 2. 2 to the power 4, second, and 0. So now what this computer has, it has a memory cell, which typically consists of 8 parts, or 8 bits they're called. The whole thing is called a byte. And we'll simply put ones in the places where we have powers 4, 2, and 0, because that's what we have in this number. And the rest will fill with zeros. So this is how the computer would store and represent this number 21. So the other things what simply computer do, they do some operations such as this processor unit which I showed you. So what it does, it can switch these numbers. And the simple operation you can do is just switch from 0 to 1 and 1 to 0. And that's what is called the NOT logic gate. The other two important operations you can do is, this is called disjunction. So you multiply the two numbers. It's like simple arithmetic. You multiply 0 by 1, you get 0. You multiply 1 by 1, you get 1. Or that's what it's called conjunction. So you sum them up. So 0 plus 1 equals 1. Actually, 1 plus 1 in this world will be equal to 1. And all what computers do on a very deep scale, it just represents the numbers as zeros and ones, and then does the simple arithmetic. But there are so many components, like billions of them inside this box, so that's why it can perform these complicated things. And from the hardware point of view, how it can be physically implemented, the device is called transistor. Probably many of you have heard about it, but simply it works as a switch between these two states. And today I would like to give you an example of vacuum tube transistor and how it started, and later in my talks I will mention about more complicated, which we have nowadays, nowadays, which are the semiconductor ones. So let's have a look at how this switch can be realized. So you have a vacuum tube, vacuum bulb, and inside of it there is two electrodes. One is anode, the other one is cathode. And both of them have some wires sticking out. So if you attach a battery source to the cathode, so what would happen, since you have a battery here and a closed loop, you will have current. And current will go through cathode and it can heat it up. So as a result of this heating, some of the electrons will be emitted out, and if you don't do anything, they will just stay around that area. Maybe some of them will go in that directions, but this will be only a few of them. So what here you can do, you can apply now the voltage between anode and cathode directly. So it's plus or minus. And as you know from physics, that charges are attracted to opposite one and they repel from the same one. So electrons are negatively charged and this anode will be positively charged. So then they will just go in that direction and you have a current here. However, so this is your on position. But if you switch the voltage, then it will be off. You will not have current because the electrons will come back to the cathode, which is positively charged. And what people noticed is that this was working well, but not good enough. And they introduced one more thing, is the electrode in between the cathode and anode. And now we have what is called triode, since there are 3 electrodes. And this electrode, it works as a door, which lets the electrons either walking in from cathode to anode or locking the door and not letting them pass this area. Well, these vacuum tubes, this how they were used in the first computers as transistors or switchers. On the other side, they're currently used as amplifiers of the signal, because just applying here some small voltage, you can control huge current or signal flowing through this cathode and anode. And if we look at the history, that's what we realized back in 1950s. This is the first general purpose computer and consisted of about 18,000 light bulbs. And you can imagine it was kind of pain in the neck to change them because they broke down very often. And the size was about tennis court. It was huge, and the power was not comparable at all to these computers.
Where was
It's in Pennsylvania.
Okay.
However, later what made a breakthrough is the discovery of the semiconductor transistor. So here you can see how it was realized of 3 pieces of semiconductor back in 1947 at AT&T lab by Barbin, Shockley, and Bertain. And later, nowadays, so that transistor was about maybe 20 centimeters. So now people figured out the technology how to fabricate them on a really small scale. So this is the example of Samsung flash memory, which the size of each element is about maybe 20 nanometers scale. So overall, today I was going to show you what the computers consist of which parts, and how do they operate on the very fundamental level, dealing with digits, switching them, and the transistor is the main working horse of our electronic devices. And later in my next talk I will describe how these more complicated semiconductor transistors which we use nowadays, how they work. Thank you.